Hello YouTube. I wanted to kind of do a video on a object I captured earlier in the summer. It is also referred to as the Butterfly Nebula, but it's actually just some nebulosity around the star Sadr. It is pretty cool. It has oxygen, it has sulfur, it has hydrogen. So it's basically an emission nebula that's really beautiful that resembles a butterfly. I will do a video in the coming days with the same object, a piece of that object imaged with a larger telescope. But for now, let's look at a wide field image taken with the Riccardi Honder's 200 f3. And what does it look like? So let's start by looking at the equipment. The Riccardi Honder's 200. It's one of my two astrographs. Very, very good telescope. Easy to use, fast at f3. It beats most of other astrographs out there by a mile. It is definitely a little bit chunky, about 25 pounds. It's not the lightest telescope, but it makes up for it with incredibly good mechanics, incredibly good systems for tilt and other things. So really, really good telescope all around. Very simple to flat field with a good panel like the Optic flat panel here. I use a small guide scope, and then at the back we have the QHY 600 mono, one of the best IMX 455 chips out there, and I like doing mono because it captures the most data. It captures 4 times more than you would with a color camera, and I live in a light polluted suburb, so no chance in me using a color camera. There's the Asado low profile 10.5-inch focuser. Again, it works really well. It does what it should. No problems, no connectivity issues. USB-C. Maybe some other people should step into the 21st century. QHY filter wheel, pretty good. Again, with the filter holders that Joel Short, I believe his name is, Buckeye Stargazer makes. You can find them on Gina Astro. Really, really good filter holders. If only QHY would ship their filter wheels with those filter holders, everything would be perfect. They stop from reflections, they hold your filters properly, and you don't want to damage a filter that's $1,200 a piece. And when you have 7 in there, it can get expensive. So this is my setup. It's all mounted on the iOptron 120 EC2. It's a really good mount. It has USB at the back, power, pretty modern mount. It's this centrally balanced kind of design. It's funky, but it works really well. It guides to, I think, 0.4 arc seconds, 0.3, even on a bad night. And because I'm imaging at 1.2 pixels per arc second per pixels, guiding, I think I can do unguided if I wanted to with this mount. So let's look at the data, and enough with the gear. HA, it's present, it's beautiful. So this is the star Sadr. It's actually pretty big. There's what resembles a butterfly, slightly tilted towards the right. A lot of dark nebulosity, a lot of this dark dust out there. Some really interesting features in this nebula, and just really beautiful formations, as you can see here. I was blown away by the details, and my wife, I think the first question she asked me, why is this so beautiful? And I'm going to quote her on that. So oxygen, it's there. It's got some weird artifacts from flats. As you can see here, I was fighting either flats or clouds. I'm still trying to find that out. I don't see them in my newer frames. And of course, even with the best filters, fast scopes have issues like this little bit of a off-axis halo. We're going to fix that. That's not even a problem. Data looks really good for oxygen. It's kind of well flat fielded, but oxygen is always going to give you some work to do. Sulfur looks really close to HA. There's a lot of sulfur nebulosity, some faint nebulosity here, and all around really impressive data to work with. So let's see what happens next. So in this video, let me get rid of some of my tools. I'm going to show you something different. So I stacked the image as you see here, and then I stretched it. I removed all the green. But one of the things I did that's different, I removed the stars and the nebulosity in 2 separate pieces. I was going to work on the nebulosity and keep the stars and add them back later with a new technique, which is why I'm doing the video, because I'm been blown away by the versatility of this technique, and I'm planning to do a narrowband image with RGB stars. So narrowband emissions and the actual true color RGB stars for a different object. Maybe two. We'll see how the skies fare. But most times I would take the stars out, I would decolorize them, and then add them back at the end with a mask and just regular pixel math, nothing too fancy. But in this situation, things got a little bit interesting, and I used James Lamb's pixel math formula. That's really good. So again, this is the stack. It looks good. I stretched it, removed all the green like most times, inverted the image and removed the green again to get rid of the magenta coloring that you see from place to place. And I used Star Exterminator to remove all the stars. After I stacked, I used Blood Exterminator like I always do in a linear format. So this is already stretched to reduce the stars and do deconvolution. And let's move on. So this is the formula I'm using from James Lamb. I will link it. I will link his video below, and you guys can take a look at it. This is what it's doing is basically using a reference star image and then doing some very fancy calculations that I'll let him describe in his video. I know math, but I'm not that good. And then there's some symbols you also have to put in, and it measures the brightness of the pixels from the stars and also the nebulosity, and calculates how to get the best values out there. Now, what I also did is after I stretched the image, like always, I basically applied a couple of S-curves. You can see that in my video, some saturations. Started looking really good, and then I applied a mask, and then I did a high dynamic multi-transform to pull some of this detail in here back. All in good. The stars are still here, right? So this is where it gets interesting. I pulled this out into Photoshop, did my typical ultra secret color mixing and texturization, but this is where it gets really interesting. So if I take this pixel math expressions, make sure your stars are called stars. It has to correspond one-to-one to this. Then just drag it on here. The stars come into view. Now, the reason I say this is really good is because stars keep their colors properly. They actually look really good. The luminance is good. It doesn't look like the nebulosity is plumped on top and then you have some stars. Some images tend to do that sometimes. So I did that, but then I wasn't done. So this is when I added the stars. But again, my quest is to show nebulosity, not the stars. If you want to look at stars, there's plenty of people who take images of actual stars, or NASA or James Webb. I'm interested in nebulosity from my backyard. I don't really want to do any kind of star exploration, planetary research. I don't have the equipment or the skills to do it. So in this case, I brought back the stars, but I did apply a simple star reduction. So just to kind of focus more on nebulosity, and then I wasn't done. This is the final image actually. I was still unhappy with the colors, so I went into Photoshop, applied a few more color mixing techniques and a few more texturization, very, very little to none. And this is the final result. I like the contrast between the red, the ambers, the oranges, and the blue. It looks really good. The goal to me, it doesn't give the image the redness it should, because red is sulfur and hydrogen are both in the red spectrum. So space images, even narrowband ones, should have a little bit of red in there. There's a lot of red. 2 of the channels are red, so that's why I do this. Plus, I want to make it unique. I want to put my fingerprint in this, and I want people, when they see an image, to kind of at least have an inkling that it might be mine, or at least somewhat different. The stars, they're still really good. I like the pinpoint stars. I like how it doesn't look like they've ever left. Sometimes when you pull the stars out and then you pull them back in, you do have some weird kind of elements, with transitional elements, where you kind of see that the stars are pulled back and forth. There's some kind of luminous difference and a bunch of other things. Now, this is especially good, this script from James on the RC and on the diffraction spikes that come with that. It's exceptional. So, James, thank you for doing this. Thank you for answering my comments on YouTube. Appreciate your work. Keep it coming. Let's push it some more. So this is the butterfly nebula, and this in the next to the star Sadr. I will do a video on doing nebulosity captured in narrowband with RGB stars as soon as I can. In the meantime, feel free to leave comments, subscribe, share this video, and if you have questions or just feedback, message me and I'll be happy to respond. And until next time, goodbye.